Good morning, teacher. My name is Joseph Martin de Carvajal, and I talk about the workshop 3 of the laboratory of yesterday. We start with the steps. Step 1 is we need to open the software, add cars, and follow the guide. In this guide, the guide tells you need to create or load an assembly. In this case, there are the steps: click in File, Open, Assembly, then right click in the text box and assembly name. Then you need to choose Pickup Truck for WDAC. Then step 2, you need to check the units. You need to check the KS system units and then select OK. In the guide, you need to vary the units to see the behavior of the graphics. In this case, we choose the IPS system units. Step 3, estimate static vehicle characteristic. In this case, we need to choose simulate full vehicle analysis, then static and quasi-static maneuvers, finally static vehicle characteristic. in this dialog box, we need to enter only the name of the test or the number of the test, and then from sprung mass you need to enter 20%, and the same for rear sprung mass. Then compare results using different loads. In this case, we entered to the mass 60 kilograms. In this case, the mass is 60 kilograms, and then we need put OK, and the software gives you the static vehicle characteristic, total weight, front ground reaction, rear ground reaction, and total CG height. This is the values for 60 kilograms, and then we choose a mass with 150 kilograms. In this case, the values have a variation. For example, in front ground reaction is the value it's less, and the same for rear ground reaction. And in the case of rear ground reaction is more, and the same for total CG height, the value is more. Step 4, simulate full vehicle system. Use the values of the guide to complete the box dialog. In this case, simulate full vehicle analysis, open loop steering events, single lane change. Then we need to put the name of a test. In this case, it's 3 tests. Then end time, number of steps. Initial velocity and gear position are stay here. Maximum steer value 5, start time 2, cycle length 3. Then put apply. In step 5, only simulate the animation results analysis. Click on the review menu, then select animation controls and appear that window, and then select the play tool. In this case is this. Step 6 is the plotting results and plotting analysis results. In this case, we compare the curves of chassis velocities, chassis acceleration, each chassis displacement, only in the lateral. We can see in this plot the behavior of the chassis velocities, chassis acceleration, and chassis displacement. In the lateral component, we can see the result in a time of 10 seconds. We have the acceleration, the velocity, and the length. In millimeters, kilometer per hour, and acceleration is gravity and time in seconds. And when we change the mass to 150 kilograms, the plotting change in this form. Only the displacement, chassis displacement, vary. The chassis displacement starts at negative in 0.007, and the only variation for this change of mass. And the questions: is there any relation between roll center and center of gravity in the vehicle behavior? We have a definition of roll center in the vehicle. This is the notional point at which the coordinating force in the suspension are reacted to the vehicle body. The center of gravity in the vehicle, center of gravity also known as center of mass, in that point at which a system or body behaves as if all its mass were centered at that point, where the weight and also all accelerative forces of acceleration, braking, and cornering act throughout it. So we can see they have a relation because the coordinating force centers in this point. So yes, they have a relation. Then how does influence overloading on driving? Yeah, the overloading on driving it's dangerous for these reasons. The overloaded vehicle will not only put the vehicle at risk but also the passengers and other road users. The vehicle will be less stable, difficult to steer and take longer to stop. Vehicles react differently when the maximum weights which they are designed to carry are exceed. Then in the brake system, brakes have to work harder due to rating of brakes, and because the vehicle is heavier due to overloading, brakes overheat and lose their effectiveness to stop the car. In the suspension system comes under stress, and over time the weakest point can give way. And then question number 3 is a problem. The problem tells you is a Chevrolet 5-door sedan without passengers or cargo are 3,100 pounds on the front axle and 1,900 pounds on the rear. The wheelbase L it's 115 inch. Determine the fore and aft position of the center of gravity for a vehicle. The essential data is the fore aft position on the CG is defined by either parameter C and B, length with uplift to the vehicle sighting and the rest of level ground. We can use the equation 1, 2, or 3. In this case, I use the equation 3. I put the value of the L, I transform that to meters, then separate in B and C the weight of front and rear. I change to kilograms and then transform to newtons. The same for rear. Then we use a third equation. We evaluate the values, then replace the values of the variables. Finally, we operate, and then we have the value of B, 1.11 meters. Then with my equation L is equal to B plus C, we have the result of C. Then we only transform to inch, and we have the values for B and C. This is all for me for my video. Thanks.